Okay, so we can use this newfound information about the scalar equation of a line to answer similar questions that we've done before, except now we don't have to go through the step of putting in symmetric and then cross multiplying, blah, 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 blah. So we're going to go straight to finding the normal and using the coefficients. So in this particular question, we're to find a scalar equation of the line through the points A, which is 3, 5, and B, which is negative 2, 6. So if we know we're finding the scalar equation, we'd like to find the normal. Now, we can't find the normal right away, but what we can do is find the direction vector. So the direction vector is going to be just found by subtracting these two points, and that'll get us a vector. So if we carefully subtract this, it'll be negative 2 minus 5, which is negative, or sorry, minus 3, which is negative 5, and 6 minus 5 is 1. So we get the direction vector is negative 5, 1. That's great, but the little shortcut that we know is we need the normal. Well, since we know the direction vector, you can use that shortcut to find the normal. So we switch the xy and make one of them negative. So why don't we make the negative 5 negatives to make it a plus 5. So now we have our normal. Once you have our normal, you know that it's those normal numbers are the coefficients of x and y. So it's 1x plus 5y plus something equals 0. And we can sub in any of the points. Doesn't matter which one. So I'm going to sub in the 3, 5 one simply because there's no negatives in it. So it'll be 1 times 3 plus 5 times 5 plus c equals 0. So 3 plus 25 plus c equals 0. So that's 28. Take it to the other side and it becomes negative 28. And therefore, the equation is x plus 5y minus 28 equals 0. And hopefully you'll agree that that is a much easier method than having to go off and find the symmetric and then cross multiplying there and coming up with the answer. Here all of our effort is put into finding the normal. Once we have the normal, the rest of the question is pretty straightforward. So there's example 2a. I've got a second example here. So I'd like to find the scalar equation of a line that goes through the point 2, negative 4, and is perpendicular to the line 3x minus 5 equals, or sorry, 3x minus y equals 5. So I'll give you a second to write that down. So this is a little bit difficult to think of, but first we got our point, so that's good. But again, we got to find the normal of our line. All we know is that one of the properties of our line that is this perpendicular to this given line. Well, now we'd have to find the direction vector of that line, but it's in scalar equation, so we can get information right away. So from this line, I see that the coefficients are 3 and negative 1. So the normal of this line is 3, negative 1. Now, let's logically go through this. If we've got this line here sitting here like this, we just found what the normal to that line was. So we found that. Now what we need is a line that's perpendicular to that. Well, guess what? The line that's perpendicular to the blue line is going to be in the same direction as the normal, which means the direction vector of our line must be the same, must be negative 1. This is our line, the one we're trying to figure out. And then we turn around and say, okay, since the direction vector of the line that we want must be 3, negative 1, we need the shortcut to get the normal of our line. Well, the normal of our line is going to be perpendicular to this. We'll switch the x and y and make one of them negative, so I made the negative 1 positive 1. So the normal of our line must be 1x plus 3y plus something equals 0. Then we'll take the given point and sub it in. So that's 2 minus 12 plus c equals 0. That's negative 10. Over to the other side is a positive 10. So therefore the equation is x plus 3y plus 10 equals 0. And that's the equation of our line, which must be perpendicular to the blue line that they gave us. And you can really see it quickly. See, the normal of my line is 1, 3, and the normal of their line is 3, negative 1. Those are perpendicular, so we're in good shape. So then all the questions you're going to do today are going to be taking this, finding normals, taking the information, finding normals, and then plugging it into this information. Now, a couple of things to be aware of. So we already noticed an example where we had a negative in front. And remember, to be in scalar form or standard form, they're the same idea. You can't have a negative in front. The other thing you can't have is fractions. So you could go off and do your work and you'll get like this. You'll get an x plus 4y minus some fraction, 6 over 5 equals 0. So that's not in standard form. We're not in scalar form. So to get rid of that fraction, we can multiply by a common denominator. So you see that it's being divided by 5. So if I multiply everything by 5, then this is a 5x, becomes a 20y, and of course if I multiply that fraction by 5, the negative 6 negative 6 over 5 becomes just negative 6, and now we have it in standard or scalar form. So that's the first beware of. The next is, you may have noticed that today's questions have only had two components, an x and a y. This only works in two space. And why is that? Well, remember yesterday we discovered that the when we were doing scalar or all the equations lines in 3 space, we didn't have a scalar equation. We just ignored that one. So a reminder of that today, in that this only works in 3 space. And why is that? Well, in 3 space, remember there's going to be an infinite number of lines to the n. And if you remember me demonstrating this before, I held the pencil up and I took another pencil and made it perpendicular. But because we're in 3 dimensions, you can take that second pencil and spin it around the original pencil, and you'll see that all of those are perpendicular. So it's impossible to define a single vector that is perpendicular to a line. So the reason that this only works in 2 space is because in 3 space there are an infinite number of normals to a line. Now, pretty shortly we're going to learn that in 3 space there is a normal, but it's not a normal to a line. It's a normal to something else. For today's stuff, you'll notice that we're only doing 2 space, so you'll only have an x and a y. So here's some practice for you. So page 185, number 1, and then 4 to 8. And if you'll look, you'll want to do number 5 and 6 at the same time because it uses the same numbers. Just asks you to find 2 different things. So that should be it, and good luck with today's work.